going to be talking about creating a better developer experience by avoiding legacy code. Specifically, we're going to talk about how we can avoid writing legacy code to create a better experience for the people who end up inheriting our code in the future. My Twitter handle is right there, AdamMick331. Follow me if you have any questions. It's the easiest way to reach me. I also do some live streaming over on Twitch under the same username. So go ahead and look it up and give me a follow there if you'd like. And I believe they will post the link in chat, but if you're looking for the Slack channel for this talk, I've put that on this slide as well. And all that information is also in the footnote on the bottom left. So you can keep an eye out there if you forget it and you want to find me in Slack later to ask some questions about this talk. Oops. So I think we should start by making sure we all have the same baseline understanding of what is legacy code, for the intents and purposes of this talk. And there's actually a lot of definitions for legacy code, and you'll get a little different answer depending on who you talk to. And you'll hear things like, legacy code is code that was written before we knew better. So now maybe there's new practices, new tools, and the code we wrote before isn't really the best way to accomplish a task. Hard to click through. Sometimes we talk about code that was written by someone else who is no longer a maintainer. So someone who had a lot of institutional knowledge about what they were writing, but they left and now no one knows how this piece of code that they managed even works. It could be code that doesn't have tests. Now, this is an interesting bullet point and we'll dive into this a little more later on. It could be code that we're unable to or afraid to change because everything might break. So we've all probably found ourselves in that scenario where we don't want to touch code because we don't know what it means for the rest of our application. It could be code without any type of comments or documentation. So a similar idea, if code doesn't have really good documentation, then no one understands it and doesn't know what to do with it. But really, legacy code could be all of the above. None of these things are mutually exclusive. We could be referring to one or any of these things. We could have code written by someone else that doesn't have any tests or documentation, and so we're afraid to touch it. But really, these are some common themes of legacy code that we're going to dive into in the rest of the talk and try to understand. But I think we should also set a baseline of why do we care? Why are we even talking about legacy code today? And the reason I wanted to talk about it is because legacy code impacts our work in a negative way, really. Legacy code can become a blocker for new development. So if a project manager comes to you with a new feature or they want to change some third-party vendor that we interact with, there's a chance we have legacy code that we have to explain to the project manager. We have to go fix this legacy code before we can do this new work. And that's a pain point we don't want to have to deal with. It can prevent us from shipping with confidence. So maybe you have some legacy code for any of these reasons, and you needed to change it to fix a bug or to try and add this new feature. But if it's old code that's undocumented, untested, you're not familiar with it, it's hard to make that change with confidence. And so you're always going to be a little worried when that next release goes out. It can be confusing and difficult to build on top of. So this is, again, a very similar theme. Like if we don't really understand the code we're working with, it's very difficult to add new code on top of it or to change what's already there. And for these reasons and many others, it's just not fun to work with. I know in my career, I've had features of a product I've worked on where whenever I'm tasked with doing something to those features, I immediately go into panic mode because there's some legacy code there that no one likes working with, and it makes certain projects just not fun. And coding's not always fun, but I think many of us, we enjoy what we do, at least a little bit, and then it's rough to, not have that feeling when we're dealing with legacy code. So these are some of the reasons that we care about legacy code. And I also want to start off this talk by posing this question, is legacy code inevitable? We talked about some of these things, like, can we avoid these things? Can we avoid the pain points of legacy code? And I asked this question on Twitter yesterday, and overwhelmingly about like 80% of people said that yes, it was inevitable. There's nothing we can do about it. And I understand that sentiment, but I'd actually like to push a slightly different idea in that, code will age with time and new practices will always arise. However, we can examine our own experiences with legacy code to help ensure our future selves and teammates have a better developer experience. So again, some things are inevitable, like people leaving the team, but we can do stuff to create a better experience and avoid some of the problems that legacy code gives us. And to do that, I'm going to start by tackling this myth that I think comes up a lot, which is legacy code was written by someone else. Whether we talk about legacy code in the sense that it has no tests, no documentation, it's confusing, whatever else, we always talk about legacy code being something we inherited. It's old code that was written by someone else. And I don't really think that's true, per se. I mean, it is true that we can't avoid people moving on to new opportunities. We can't help that. But one day, you will be that someone. You will move on to a different opportunity, a different company, a different role within your current company, whatever else. You will leave behind code for someone else. And also, even if you don't do that, your past self from 1 year ago wrote code like a different person. So all the pain points of like inherited legacy code from someone else on our team, we often feel that way about our own code a year or so later, and what I'm really trying to say with all of this is only you can prevent legacy code. You may feel like you have no control over the legacy code you inherit, but you do have control over the code you leave behind for other people. And so that's what the rest of this talk is about, is what steps can you take to prevent your future teammates from dealing with legacy code? So let's start by exploring some causes of legacy code. And the first one, I think, is an interesting one. Legacy code doesn't have tests. The reason I say this is interesting is because when I started writing this talk, and I was writing down all of my ideas for legacy code, I never considered unit testing. Because in my definition of legacy code, it never had anything to do with tests. It had to do with the maintainability, how easy it was to understand, how old it was. And so I asked someone on Twitter that I had this conversation with, what about code lacking tests makes it legacy? And I got a beautiful answer from Jorge Coca. He said, if you have to work with code that you did not write and is considered a candidate for a refactor, not having tests makes the task incredibly complex and error-prone. However, if tests are present, then you have a security net to help you validate some assumptions. And I realized this was similar to my understanding of legacy code and what I talked about earlier, in that it's code that is hard to understand and hard to ship with confidence. But I never really thought about the role that testing plays in that. So we're going to dive into this a little more, because I think this is a really great point. But we want to look at how to avoid legacy code, right? And I don't think it's enough to just say write tests. I think it's a little more complicated than that. Because there's two reasons that code doesn't have tests. The first one is that we just chose not to write any. Some of us are lazy, we don't prefer TDD. Maybe we think that the class isn't necessary to unit test, or we have a good QA team to do it for us. But the other problem is that sometimes our code isn't testable in the first place. And if our code's not testable, then not only can we not write, not only do we not want to write tests, but we can't if we tried. So let's look at an example of untestable code, or talk about what I mean by that. So untestable code is code with a lot of static references. Code that's referencing some singletons that exist outside of our class, and it could be managing some global state that screws up our tests in ways we're not always ready for. And in a similar vein, it's code that doesn't leverage proper dependency injection. And I'm not going to say like what dependency injection framework you need to use, if any, but just that if you're not using dependency injection, but rather having strict references to certain dependencies, it's going to cause the same problem as you're going to deal with sort of global state from these dependencies that you can't deal with and in tests. And interestingly enough, like these unclear static dependencies sometimes indicate fragile code that people are afraid to change anyways. And so it has this double effect of it makes it difficult for us to write tests, but it also brings up the other red flags of legacy code, and that like this is code we might be afraid to change, or it's difficult to understand. Why are we using this certain dependency? What happens if I remove it? Is it affecting some global state I don't know about? All of these fun things. So let's look at a more specific example with some code here. So in this snippet, we have a profile view model that has a private function to load the profile. And it has this catch block where when an error occurs, we call myErrorTool. This could be anything, Firebase, Sentry, Crashlytics, etc. We would call myErrorTool.getInstance.logException. And why is this line of code bad? Well, myErrorTool as a static reference is difficult to mock for unit tests. There are some tools that make it a little easier, like PowerMock, and even MockK if you're using Kotlin can help a little bit. But there's also the concern that, if we forget to mock it, we don't want to risk our negative tests actually logging errors to our production tool because they're unit tests, right? And this tool could be running setup that crashes our test. So I've seen this example before where, maybe the error tool expects to be initialized on an Android device, and maybe it looks for the main looper or something like that. But when you run this on a regular JVM unit test, it doesn't know how to handle that. It's not used to running strictly on the JVM. And so as a result, your test will crash. So this code is bad for a number of reasons we'll continue to talk about, but specifically I want to focus on why that makes it difficult to test, which leads into the quick solution for that, which is we could just inject our instance of myErrorTool. And so we can say our view model accepts the error tool, the type is myErrorTool, and I'll actually change this after the slide, I think, to make it more specific. But I wanted to clarify, this is a generic problem, whether you're using Firebase or Sentry or Embrace, like you're gonna run into a similar issue. But if you inject that instance and you remove the static call to get instance, then it becomes easier inside a unit test to pass some sort of custom implementation of myErrorTool, if you're allowed to, which segues into the next slide. But this is the quick solution. I wanted to explain that like you have a static reference that's difficult to control in your unit tests. If you inject it instead, now you have a way to provide an instance in your unit test that you have more control over. But we still got a problem here. The problem being that tightly coupled dependencies become legacy code. And to clarify what I mean by tightly coupled dependencies, I mean, companies change third-party vendors. You might go from mParticle as your analytics tracker to something like Segment, or you may change error reporters going from Firebase to Sentry or Embrace. Companies may change tech stacks. They may go from REST APIs to GraphQL. So you might go from using something like Retrofit to Apollo. New image loading libraries are made every few years. And all of that to say is that code that doesn't allow these things to be changed is likely to become legacy code, because some of these changes might be crucial to new development or just for maintaining a modern code base. And if you don't set yourself up to replace these tightly coupled dependencies, you're going to end up with legacy code that's really hard to deal with. So let's look at how we can fix that. Revisiting this line where our code base strongly relies on myErrorTool. That's a problem because our class is strictly tied to the myErrorTool method contracts. So if this tool changes its method signatures, or if we try to change to a different one and it uses a different method, let's say it goes from log exception to log error, right? That's just more code changes we have to work around. And despite dependency injection, this will make swapping our error tool difficult. So we've solved the testability problem, but we haven't solved the problem that if I want to replace Firebase with Embrace, that becomes very difficult to do. So what's the solution? The solution is to wrap any third-party dependencies we deal with. And the way we do that is by creating an interface. Let's say we call it error reporter, and it has a function called report error, and it takes in some throwable that went wrong. And this interface is going to be an interface that you own in your code base that you decide the method contract you want to abide by. And then we can implement that interface with any sort of concrete implementation for one of our third-party tools. So here we have a Firebase error reporter that implements this interface. And inside the report error method, we log an instance strictly to Firebase. And it's important here that when you implement this interface, you try to use the class name to be specific. And that's okay for this class to be tightly coupled to Firebase. One, because we've specified it in the class name, so there's no surprises there. And two, it's implementing an interface, and we know that that interface can be used upstream to make our lives easier as far as the concerns we've already talked about. So here's the updated method or constructor for our view model, where we're going to take in an instance of an error reporter, but we specify the default as Firebase. But this helps us a lot because, this helps us a lot because it makes it easier to replace Firebase error reporter with some other third-party tool. And because it's an interface, we can also create our own mock or fake implementation to be used in unit tests without dealing with complex like power mock and tightly coupled to Firebase specific method contracts. We've pulled all of the Firebase logic away, and we've made our view model depend on an interface that we have control over, which is really important. So to recap some of the benefits I just talked about, easier to provide fake and mock implementations and tests when we wrap our dependencies like this. Easier to entirely swap third-party tools, which is an inevitable product decision. It's easier to update tools, and we'll look at examples of these last two in the next couple slides. Oops. So here's an example of, this is coin syntax, but again, you could be using any dependency injection manager. But what this code is saying is you have some core module that defines all of your core dependencies for the application, and we want to create a singleton for an error reporter. And in this case, we have a Firebase error reporter is what we want our project to use. But by wrapping the dependencies, isolating it into this core module, we could change one line here. We could create a new Sentry error reporter, replace the Firebase line, and boom, our entire app is now updated to work with Sentry instead of Firebase. And so this avoids a lot of legacy code pain points in that we can entirely swap out third-party tools really easily, just because we wrapped it behind an interface that did what we wanted. It also makes it a little easier to update our dependencies. So an example I talked about earlier is like, let's imagine the Firebase library changed their method contract from log exception to log error. Now, I don't know if this is a valid real world scenario, but method contracts do change sometimes. But for our purposes, we think as a client, that doesn't matter to me. I just want to still report an error. And so we've isolated it into the report error method of our Firebase error reporter. And now we can just change a couple lines right in there. And again, our whole project is now ready to go with the latest Firebase setup. And we didn't have to do like a find and replace around the entire project. So this, again, avoids so many legacy code pain points that we're used to dealing with. And I've talked about that a little bit, but just to repeat myself and talk about why these steps are so important, what we were able to avoid here. We have testable code that we can ship with confidence, assuming you've actually written the tests now that you have testable code. But get testable code, write the unit test, you can now ship with confidence, something we couldn't have done with the sort of legacy code that we were looking at in the early slides. We have decoupled third-party tools, giving us freedom to swap vendors with ease. So when we go to work on a new project in the future or a new feature, and someone says, oh, well, we need to use a different analytics tool now, we've maybe created our own analytics tracker interface already, and it becomes very easy to implement that new tool without saying, I have to go refactor a bunch of legacy code before I can do all this. And we can confidently upgrade our third-party tools and limit the code changes required. So just these two steps we looked at, better dependency injection, wrapping third-party libraries, avoids so many concerns from legacy code. But there's still more that we have to deal with. And it's this idea that legacy code is code no one on the team understands. And what I really think that this means is legacy code doesn't have documentation. And I'm probably getting a lot of interesting takes right now because people love or hate documentation, but I think it's really important. And I think that code that doesn't have helpful documentation, emphasis on helpful, is bound to become legacy code. And let's talk about what I mean by that and like how that process happens. So what happens is some author is writing code and they understand what they're writing because they're doing it, right? And the author felt that their code was self-documenting. They felt that the variable names and method names that they were using made sense to them. Maybe it made clear sense to the person who was reviewing their code at the time in the context it was written. But so because of that, the author doesn't provide any additional context. It made sense to the author, it made sense to their teammates, but the author leaves the team only for someone else to find this class much later, and the new team has no idea how this code works or if it can be changed, why it was implemented. They don't have any of this institutional knowledge that the author had when they were writing it. So this is an example how this could be code that leveraged good dependency injection, wrapped third-party libraries, but maybe there's still something about it that was missing context from documentation. New team members aren't going to understand it at all. So we'll look at some tips for fixing this. Specifically, looking after future developers with our documentation, because that's who we write documentation for. We don't write it for ourselves right now because we usually don't need it right now. We're writing it, we understand the context. Documentation is meant to be read by someone in the future, and we want to help them. So these tips, keep in mind that idea that we're going to be looking after our future teammates with the documentation we write. I will link to these in Slack later, but there's a footnote at the bottom of a blog post I've written on this before, writing good code comments. But we'll highlight a few examples here in a second. So one example of where documentation can really help avoid legacy code is to document when you rely on external code samples. So consider this example where you're making some page that uses, well, let me read this comment to you, and that'll explain it. So we could say feature XYZ requires a view pager-like experience, but without the user being able to control each step, like swiping the pages. We've implemented a view pager that rejects any user interaction. And then we link to the Stack Overflow answer where this came from. So this allows future devs to understand why this class was added and explore if there are new first-party solutions. So I bring up both of those because imagine yourself coming across this code without this comment at all. You don't know what non-swipeable view pager is. You don't know where the code came from. Did the author write it themselves? In this case, they didn't. They copied it from Stack Overflow, but you wouldn't know that. And context of why it was added is really important to explore new solutions. And I brought up this example specifically because I've implemented this before. This comment and example was from a previous project of mine. But now with the latest ViewPager 2 library from Android, you can actually disable swiping first party. You don't need to go to Stack Overflow and copy this anymore. But because we explained the feature that was used and why we added this code, it allows future developers to say, they implemented it for this reason. There is now a new first-party solution that solves the same problem. Let's rip this out and replace it with ViewPager 2. But without that comment, you'd always have a little hesitation wondering, can I actually replace this with ViewPager 2? So if you're relying on external code samples, and this is a little more than just external code samples, this is, any sort of workaround that we talk about, but really document those things. And if you rely on external code samples, link to the source, because if you ever find a bug in this code, that allows future developers to go see where you got it from originally and see if other people are running into the same bug, make sure they get the right solution. And in a similar vein to what I just talked about is we want to document when we work around library bugs. So again, something that makes sense to us in the moment. If we look at this, we could say due to some libraries issue, we needed to implement this workaround to prevent a crash on Android devices running API 21. This is a really important code comment that avoids this code from becoming legacy code, because without any comment, you have some code that's working around some third-party library bug. And really only the people who are on the team when this happened are going to have any idea what that means. But this comment solves a couple issues. This allows future devs to understand what the code is doing and explore if the bug has been fixed in a subsequent library update. In this comment, we linked to the company's issue tracker to say this is the specific bug we are working around. The comment also clarifies specific criteria that was causing the crash. So a new developer who finds this code can say, there was this issue in the third-party library and it crashed on API 21. We know there's a new library version, so let's upgrade, and then let's test our application on API 21 to make sure it's fixed. But again, without this context into the issue that happened or what devices need to be tested, this is a big red flag for stale code that no one would understand and would be afraid to rip out. Maybe one day in the future you update your min SDK above 21, but this code is still going to be there and no one's going to understand that it's safe to remove now. So these little comments, anytime you work around a third-party problem, go a really long way in looking after future developers. And another example, and you can take this one with a grain of salt, but I thought it was helpful to include, is like document when you use libraries for specific use cases. So here's some Gradle code where we're implementing the Android X security library, and we're saying we use this dependency so we can use encrypted shared preferences. And maybe the security library was a bad example now that I look at this slide, but the scenario I'm thinking of is I've joined projects that have existed for a while, and I've combed through the build.gradle file at some of the implementations, and I see some libraries that don't seem like industry standard, like they're not an Android X library, they're not like retrofit or RxJava, and I'm thinking, what did we ever add this dependency for? Is it only used for one specific feature? Is it used throughout the project? That's sort of the confusion that leads to legacy code, and that like we have this dependency, maybe it made sense at the time, but now maybe there's a new dependency, a new first-party solution that we could use. And so it could be helpful to document libraries for specific use cases. You could also extend this if you're ever stuck on a specific version. So a previous app that I worked on, prior to bumping our min SDK to API 21, we couldn't actually update to the latest retrofit library because retrofit, a number of versions ago, set their min SDK to 21. So we had to use something like this to say, we have explicitly used this old version because we're still supporting older Android versions. But that helps avoid a lot of confusion for people in the future. And I talked about all of that with that. Forgot there was another bullet point here. But just to reiterate, this allows future devs to update version numbers with confidence as well as understanding what to test and why the library was chosen. And I want to reiterate why this documentation matters so much, why I chose these examples. And I'll sum that up with this important statement is, we're not trying to prevent code from becoming obsolete and outdated. We don't have control over that. We're trying to help the future maintainers respond accordingly. So I really think we should keep that in mind. Like, we can't change, that Android comes out with a view page or two and makes a better solution, but we can document what we're doing today to help our future teammates be able to respond accordingly. And so even if that code feels like legacy code because it's out of date and there's a better solution, it doesn't have all the pain points of legacy code because you've now guided your future teammates to be able to adapt to that. So I think that's really important. And we'll recap this is a recap now of the talk. So I believe we're going to do questions in chat. Feel free to start typing them if you get a moment. That way I can answer them as soon as I'm done. But let's get through this recap real quick. Writing testable code with decent coverage helps future developers refactor with confidence. So this avoids a lot of legacy code pain points just by writing testable code and also testing it when you're done. Wrapping dependencies allows future developers to update and replace tooling easily. Again, another legacy code pain point that we can avoid ourselves. And documenting certain decisions allows future developers to confidently understand, refactor, and replace code written by someone else. So those are three key themes that I hope you picked up from this talk. But if I could leave you with one really important message, something I really hope you take away from this talk, it's this. The goal isn't to completely eradicate legacy code. It's to look out for our future teammates by not leaving behind rigid, confusing, and unmaintainable code. We can't stop things from aging. We can't stop new tooling from coming out, but it doesn't mean we shouldn't consider our future teammates and make sure we're looking after them and making sure they have the best developer experience possible. And with that, that's all I've got. So I will switch over to the other thing and see if there's some questions. Thank you. Shannon, I can see chat. I don't know if you want me to go ahead and read the questions out and answer them. Is that easiest?
Yeah, that would be perfect. Awesome. We can also, yeah, however you want to do it.
Sure, I can do that. So the first question I see is, so essentially using the decorator pattern to abstract third-party tools helps remove potential breaking changes from legacy code. I'm not familiar with the word decorator pattern. I'm assuming that's what I did by creating an interface that defines like a very similar contract as the third-party tool, but abstracting it away. Yeah, that helps remove potential breaking changes for sure. It also helps you swap tools. Like I said, we could create an instance of a Firebase error reporter, but then it becomes very easy to also make a Sentry error reporter and swap out those two error tools very easily. So that's one big benefit of it. Let's read this next one. This is good when at least some core architecture is written properly and we can just edit the view model to use dependency injection, etc. What about when it's at such a bad state that we are still at God fragments, event buses, etc.? Any tips for such big level of legacy code? Yeah, so my biggest tips are to look for any sort of small incremental refactors. So one thing is the documentation aspect. If you have some legacy code that you're already dealing with, some God fragments, the least you could do is go through one day and just make a bunch of comments that you think that like you have this knowledge of, but the code doesn't exactly say this. I worked on a team where someone left the company. They had a feature that was kind of their baby and no one understood. And I made one pull request, just adding documentation to that feature, just to help us in the future. I think that's one step. Another is to see if you can consider some sort of hybrid process. On the last point I just answered on, like wrapping dependencies. So let's say you have littered throughout your code base, you're using Firebase or Crashlytics, and you have a bunch of crashlytics.log exception, you know, you could leave those, but still make an error reporting interface, create your Firebase error reporter, and start using that on your new features. And make that a standard. And what you can do is over time, slowly pick away places where the static reference exists and replace it with your new dependency injection approach. So keep in mind that it doesn't always mean like ripping out all the legacy code and replacing it at once. You know, we can do these sort of incremental steps. And one thing you can do if you have your own static instance, so not like Firebase, but if you have your own static instance in the code base that does something, you can leverage the deprecated annotation to deprecate the static instance and say, use this cleaner dependency injection approach moving forward. And then inside your code base, you will see strike through anytime you reference deprecated code. And so it can still be there, it can still be supported, but now you've signaled to developers, hey, we're moving away from this. And that could be a however long of a timeline you think it needs to be, but that's one way. And I think there's a lot of other tips, and I think that'd be a great conversation to have in Slack later. But I hope that gives you a couple ideas to take back to your team and get started with. Thank you for all the great comments. I really appreciate that. Last one, having abstracted out our crash reporter would have made updating it much easier. Yeah, definitely is something that, you know, wrapping dependencies is a lot of upfront work because it may feel like, it feels like work to create an interface that's only going to have, you know, one implementation because you know your company uses Firebase, but one day down the line that could change, and doing a little bit of upfront work saves you so much time in the future. And that's something that, you know, unfortunately you only learn with experience, but I hope you've all learned from this talk. I didn't get to tell my story time in the beginning, but part of what inspired me to do this talk is I moved from a company that had a 5 or 6-year-old app to working for a startup where I am building the first version of an Android app. And so I actually had to ask myself all of these questions, like what are the legacy code pain points that I hated dealing with joining a team, and how can I start this code base to avoid that for, you know, people who are eventually going to join onto this project. And I know I can't avoid all of it, but just thinking about it and having it in my mind and trying to make a conscious effort will get you a lot farther than not doing anything at all. And that's why I said it's important to remember we can't completely eradicate legacy code, but we can look after our future teammates and help them out the best we can. Any smart way / blog that talks about it or whatever to manage and convince the business people about the value of putting time to work on this instead of new features, etc. I find it hard to prove that a delay now to work on fixing such problems will lead to a speed up in the long run. Yeah, that's hard. And I still don't know the right answer to that. I'm still always struggling between I want to fix all the tech debt and I need to deal with people who are coming to me and saying, we need to make money. I would see if you can look for any past examples where this has already happened. So it is hard to talk about it in the hypothetical to say like, if we do this now, we save time in the long run. But if you've already been through this, if you have a feature in your product that is already poorly designed, you know, maybe you have a profile page that's a super legacy page, and every time they want to update the profile, it takes you longer to make changes to the profile page than it should have. Like, try to bring up that as an example. Say like, you understand all the problems we've seen with the profile. We've spent X amount of hours on, you know, changes that should have taken 1 hour. And so like, it's important that we fix this now because over time, you know, we can spend 1 hour on these changes instead of 5 every time. Or I know that's vague, but it's like, that's my sort of starting point. Do you have a specific feature in your project that already suffers from this problem? And can you use that to provide more concrete of an explanation of the problem rather than just a hypothetical save time in the long run sort of thing? That would be my advice. Thanks for these really great questions. Yeah, yeah, it is hard. But again, I think that could be another great ongoing conversation for Slack as well. But I hope that was a good starting point for some people.
And that's a great note. The Slack channel will remain open for quite some time if you'd like to continue posting questions or thoughts and continue the discussions beyond the today.
Yeah. Awesome. Thank you so much for coordinating everything, Shannon.
Absolutely. It's a great talk. Thank you.
Yeah, doesn't look like there's any others, so I'll see everyone in Slack. Thanks so much.